Hello, welcome back to the Geography 300 WVU video series. This video, is looking at 4 different types of attributes for our data. And the basis for this has gone back several decades in the field of statistics, and is a pretty commonly used framework for trying to understand the structure of our attributes and to use that to guide decisions of what we can and cannot do with our data in terms of the kinds of statistics we use or the conclusions we may reach. This framework is called Noiroir, N-O-I-R, as an acronym, and you can see here the 4 different types of attributes or variables that make up that acronym: nominal, ordinal, interval, and ratio. We'll take each of these in turn. First one, in a way the simplest one, and the one that we can do the least with, is nominal. They are an attribute that is a name or a category. So, as an example, something like the land cover type, or the name of a county, or some kind of, say, political classification. Did the county vote for the Republican or for the Democrat? Each of those is a category. Because it is a category, you cannot say one is greater than the other. For land cover type here, we cannot say the value of forest is greater than the value of grassland. They are simply 2 categories, and you cannot make an assessment of greater than or less than or any comparison like that. This means we are limited by what we can do to look at what is most common. So we can say forest occurs more frequently than grassland in Monongalia County, but we cannot make an assessment of the value itself. This means we can do a statistical summary, a descriptive statistic called the mode, which is to say what is the most common value. The thing is, we cannot basically do anything beyond that. Where we can move beyond that goes into the next category, ordinal. In ordinal data, there is an order. There are ranks, but that is basically as far as it goes. An ordinal scale or an ordinal variable that you've worked with a lot probably by now is the SEI scale. So when you're filling out those questions at the end of the semester, you would say something like excellent, good, fair, satisfactory, poor. I can then say, because there is an ordering, I can say excellent is better than good. Good, therefore, is greater than fair. They do get turned into numbers, 5, 4, 3, 2, 1. However, those numbers are only basically encoding that order, or that ranking of excellent is the highest at 5. We can still do the mode and say more people rated this instructor excellent than any other rating. We can also do the median. The median identifying basically the middle value in that order. So we can say the most common element or the most common rating was excellent. We can also say half of the students rated that instructor good or better. So even if it is not the most common, say if 40% of the students rated somebody excellent, 30% said good, 30% said fair, half of the students would say good or better. That is the median, whereas the most common is the mode. As we then move in a way into more complexity, as well as, in a sense, more restrictive assumptions about our data, we move to the interval scale. I put it here as constant spacing. So whereas for the SEI scale, or as it's ordinal, yes, we turn excellent into a 5 and good into a 4 and fair into a 3. However, we cannot say, in effect, the difference between excellent and good is the same as the difference between good and fair. Those are sufficiently subjective assessments that you cannot say that difference from one rank to the next is guaranteed to be consistent. That consistency is guaranteed with an interval data set. The intervals are appropriate, the intervals have meaning because that constant spacing is present. True interval data is actually not super common. The most common one that we have is temperature. With interval data, with the temperature, we can still do a mode, we can still do a median. Now we can add to this the mean to say what is the average daily high temperature for Morgantown during the month of January. That average is now possible. The key thing for interval data is that the value of 0 is ultimately arbitrary. So if you think about the Fahrenheit scale, I can say that the difference between 20 degrees and 40 degrees is 20 degrees Fahrenheit. Likewise, the difference between 40 and 60 is an additional 20 degrees. That's why it's interval. That is consistent. I cannot say 40 degrees is twice as warm as 20 because 0 is arbitrary. There is no inherent meaning behind 0 degrees Fahrenheit other than just sticking a number on the scale. I have heard, I don't know if this is strictly true, but I've heard that the Fahrenheit scale is based upon the climate of wherever Mr. Fahrenheit lived, where depict the coldest temperature typically experienced in a year as 0, and the hottest temperature experienced in a year as 100. At that point, if Mr. Fahrenheit then lived, instead of, the name sounds German, so I'll just pick Germany. If instead of living in Germany, the person lived in Egypt, in a much hotter desert climate, 0 would be much higher. So would 100 for that matter. If instead they lived in Siberia, 0 and 100 would be lower. So that is arbitrary, based strictly upon where the person lived. That set the scale. So there's no inherent meaning as 0 degrees Fahrenheit other than just a place on the number line that is 5 degrees colder than 5 degrees Fahrenheit and 5 degrees warmer than -5. If we do have a meaningful 0, that moves us over into the last category here. Which is ratio data. Now with ratio data, I'll give an example here as, I'll give two, distance and population. And I put both distance and population here as a way to point out 0 has meaning. 0 is a meaningful starting point for your measurement, basically. So if you're measuring the length of a road or a road segment, well, one end of that is marked as 0. And you go from there. That does not mean you will ever find the value of 0 in your data set. You do not have to have the value of 0. The value of 0 does not even need to be plausible. You're never going to have a road of length 0. There's just no point. It's going to have to go from one place to another, therefore there is some distance. However, the 0 is a meaningful starting point for that measurement. Likewise, you're going to be very hard-pressed to find a county that has 0 population. But that's a meaningful starting point. If you cleared everyone out, you cannot go lower. Therefore, 0 as the base of an empty county, so to speak, is a meaningful starting point for measuring the population of that county. One way to check here is whether something is ratio or interval is to change the units and see if a ratio changes. So with temperature, if I say, okay, the difference between 40 and 20 Fahrenheit, if I wanted to check, is that a ratio scale? Well, 40 is double 20. Okay, let me convert to Celsius. Now, I have 40 becomes about 4 degrees Celsius. 20 becomes about -6. Obviously, that ratio of 2 to 1, 4 is not twice -6. Therefore, it cannot be ratio, because the ratio changed just by changing the units. That puts it as interval. For distance, a road that is 10 kilometers is twice as long as a road that is 5 kilometers. If I change the units, is 10,000 meters versus 5,000 meters. It is 6.2 miles versus 3.1 miles. That ratio of the longer road is twice the length of the shorter road persists and is consistent no matter what unit of measurement I use. That puts it into the ratio scale. Now, this is that standard Noiroir typology. There are, however, things that may or may not fit very well. So we can have things like the compass direction. If I have a compass direction, first off, it can only go from 0 to 360. Having an upper limit, some people have argued, in many cases in practice it doesn't make much difference, Now, some people have argued that the presence of an upper limit means it doesn't fit any of these scales. The idea being, in, say, a ratio scale, you can always double it. Well, you can't. You can't do that with the degrees because, well, you cross over 360 and it becomes 0 again and you go back down. Even more to the point, if I look at the mean and say I can do the mean for a ratio scale. If I go just to the east of north, I'm at 1 degree. If I go just to the west of north, I get 359. Any sensible average of these 2 points along this circle should be pointing due north. However, the average, or the mean, of 359 and 1 is 180 degrees due south. That just seems kind of weird in a way, so that is another argument that this doesn't really fit the scale. So we can say it is not any of these. And you can think of others that would not really fit this Noiroir typology very well. And especially something like a picture. A picture of a place that contains information about it, that contains information about that place. It may not even be considered a traditional attribute, and it certainly doesn't fit this framework. So even though there are these limitations, this idea of not every attribute type can really be put into this scale here. This is a commonly used scale of breaking down our attributes into nominal, ordinal, interval, and ratio types so that we may use that information and that typology to guide the choices of statistics that we apply and use to analyze our data. So as always, if there are any questions, please ask during the Q&A or send me an email at your convenience. So I'll see you at the next video.